Good morning. Um, Welcome back. We are going to be starting Chapter 7. Chapter 7 is really kind of cool. It's all about earthquakes and what causes them and kind of why the ground shakes. Earthquakes are one of those things that we don't necessarily experience too often in our lives, but once you do experience one of them, uh, it is just a very unnerving kind of thing. The ground is not supposed to move. So when the ground does start to move, uh, it really does kind of catch your attention. But the thing with earthquakes, though, they happen every day, thousands of times every day, all over the world. But when we get started here, let's look at our um, assignment notebook. Let's get that thing filled in, please. So here we go. So it looks like what we're going to cover today, we're going to just take some notes from section 7.1. It won't take very long. And then you are going to fill in your assignment notebook right down here. You're going to be assigned 3 questions on page 225, questions 1, 2, and 3. Those are going to be due the next day that we meet, and then we will correct that the next time that we meet. So with that being said, make sure that that gets filled in. And if you ever need to just pause the video to fill in things, please do that. Teachers, if you're showing it in the room, pause it whenever the kids need you to. If you're watching it at home, virtual kids, or if you're watching it in class by yourself, that's the beauty part about recording these lessons and having these lessons available to you, is that you can pause it and you can get caught up. So let's start by looking at our notes. So in our notebook, if you could take that out, please. Title it Chapter 7, Earthquakes, and label it 7.1. I've underlined things throughout here. Those would be the main things that I'd like you to make sure that you get copied down into your notes. So let's get going. So the main thing we have to remember is, if you remember, the Earth is made up of all these tectonic plates, these big, huge slabs of rock that are just floating right on top of this asthenosphere. That lithosphere, the solid part of the rock, it's just kind of skimming over the top of that magma of the mantle and the soft rock of the asthenosphere. Well, when those big blocks of rocks are moving around, they run into each other once in a while. And when they run into each other, sometimes they'll move and sometimes they won't move. Sometimes stress builds up. Where they are moving, where they're running into each other, where there's a break between them, well, that break is called a fault. A fault is just a crack in the surface of the Earth, in the lithosphere, that hard part, where the rocks are either pulling apart or pushing together or sliding past each other. Sounds very similar to what we talked about with transform and divergent and convergent boundaries. A fault is, the only difference between that is that the crust is broken there, and it's where they are pulling apart, sliding past, or pushing together. Now, when they are being pressed on or pulled apart or pushed together, stress builds up. And wherever that stress is built up, rocks will break, rocks will bend, rocks will crumple. We've talked about that. But that stress that builds up eventually has to get released. Just like if the kids are loud in the classroom and I told them once, I told them twice, I told them 5 times to be quiet, stress builds up. Eventually, the stress is going to have to be released. I will yell at them then, or maybe I won't yell at them, but I will get angrier and angrier, and stress builds up, and it has to be released. So, when that is released, that is called an earthquake. When that stress inside that rock, where they're running into each other or they're pulling apart from each other or they're trying to slide past each other and they're stuck there, when it is released, that becomes what we call an earthquake. It releases that that stress suddenly, and the ground begins to move. Now, it may not move very far, it might not move a lot, but if you have a tectonic plate that moves 4 inches, but it moves 4 inches over a fault line that is 1,000 miles long, everything along that fault line moves 4 inches. And that can cause quite a bit of chaos there. So one way that you can kind of test this out is if you do this. If you take your hands and you push your hands together, try to push really hard together. And once you're pushing it together, try to take your right hand and try to push it forward, and take your left hand and try to push it back towards you as you are pushing in. As you're pushing in, your arms push so that they're shaking, and then all of a sudden it just slips. And that slip, that stress that's built up, you're building up stress when you're pushing together, and it slips forward, that would be equivalent to an earthquake. This would be a tectonic plate. This would be a tectonic plate. Where they're meeting is a fault. When they're pushing together, the stress is built up. That's the stress. And then when one slides forward, that's the earthquake. When one finally releases, that stress finally releases, that is an earthquake. So, now where do these things happen? They happen mainly along tectonic plate boundaries. Doesn't mean that they can't happen other places. It just means that most earthquakes occur in these areas as well, where one plate is running into another plate. Where there are faults, there are earthquakes. And the main thing also is the earthquakes, they all take place in just the lithosphere. Just the lithosphere. Earthquakes don't dip down into the mantle. Earthquakes don't dip down into the asthenosphere. They only stay in that cooled, rigid rock area that we know as the lithosphere. So, now they are classified by how they move. And the three types that we're going to kind of cover here are normal faults, reverse faults, and strike slip faults. While we're talking about these, you might want to open up your book to page 224 and page 225. That'll help you when it comes to what you put into your notes as far as your drawing that you're going to have to do. But on page 224 and 225, they talk about these normal faults and what they look like and how they act and why they act the way that they act. So, with that being said, that's all you have to write down for this page right here. I'm going to keep moving on to the next page. If you need to pause it to finish up writing, by all means do that. Now, the first one is a normal fault. Well, with a normal fault, here are the three main things that you have to kind of pull from the normal fault. Normally they happen at divergent boundaries. Now, if you remember, divergent boundaries are where they are dividing, where they are pulling apart. Earthquakes along normal faults are caused because of that divergent kind of stress that's built up. Now, when that stress is built up, this first part really is the important part about how to identify a normal fault. When they do finally break, when they do finally, the stress finally is released, one of those sides of the rocks being pulled apart slides down relative to the other. The other one stays kind of where it's at. Now, if you look in your book on page 224, they talk about that there. They show that there. If you look at my handy dandy, very scientific tissue boxes of science. Oops, I gotta move this way. You can kind of see that each one of these boxes has an arrow on it. And the arrow is showing the direction that they're moving from each other. So this tectonic plate and this tectonic plate are moving away from each other. That would be a divergent boundary. Now that first thing that you wrote down that says the blocks of rocks above a fault plane slides down relative to one another. The fault plane is this line right here. Right here. Oops, right here. This is the fault plane. This is where that stress is building up. This is where the rock is still solid. They're running it, or they're pulling apart from each other, but it hasn't broken yet. But when it does break, along that fault line, what happens is these are trying to pull apart. But rock is solid, and rock doesn't really want to fall apart. So as they're trying to pull apart, what happens is when the stress is released, one of them does slide down from the other. Now you'll notice they're kind of both right at my chin level right now in the picture. But in a divergent boundary, as they're trying to pull apart, the stress is released, the rock is cracked, the rock does move eventually, and then one of them slides down compared to the other. That's what that first statement means, is that relatively this one moves down compared to the other. If you notice, the one here in this hand is still at chin level. This one right here is below chin level. So that is a normal fault. In a normal fault, it's divergent, and one slides down compared to the other. Excellent. So, let's get back. Now on page 224, it does say to draw that into your notes. There's a really nice picture. Make sure you include all the arrows and where the fault plane is and all of that good stuff. Make sure you include like the word pull, because that's where they're pulling apart. If you need to take some time, pause it, do a quick sketch in your notes. Otherwise, I am going to keep going on. The second type of fault is something called a reverse fault. Now, in a reverse fault, it is almost exactly opposite of a normal fault. Almost exactly opposite. So, the first one says the blocks of rocks move along that fault plane. One moves up relative to the other block. Whereas you notice in a normal fault, it said one moves down relative to the other. In a reverse fault, one moves up. Instead of the rocks being pulled apart, they're being pressed together. And instead of at a divergent boundary, it's at a convergent boundary. So every aspect of this is completely the opposite of a normal fault. So if you can remember what a normal fault is, then a reverse fault shouldn't be that hard to remember either, because it's the exact opposite. So here with my normal fault, or excuse me, my reverse fault boxes of science, fantastic, fancy ones again. Oops, wrong camera. This one right here. Now you'll notice that the arrows are pointing in to one another, towards each other. And the fault plane is still right here. So this plate and this plate are running into each other. and they're trying to get past each other. But they're stuck. Stress is building up. Stress is building up. This guy and this guy are pushing into each other. And eventually, that stress is released. The rock breaks. And then instead of dropping down with one another, you notice they're both at my chin, what happens here is one slides up compared to the other. So that's why it is a reverse fault. It is reverse of everything that a normal fault does. So again, they're pushing together and one will slide up as the rock breaks. And as the rock breaks, it slides up. Notice this one still stays at chin level. This one right here slides up over my face. So, again, convergent boundaries, stress builds up. As the stress builds up and it finally is released, one slides up compared to the other. That's simple as that. That is a reverse fault. And then the last type of fault is this one right here. Is a strike-slip fault. Well, a strike-slip fault is where they try to slide past each other. Not away from each other, not towards each other, but past each other. They push by each other horizontally. And if that sounds like a transform boundary, it is, because that's where they occur. They occur where tectonic plates and faults are trying to move past each other. Big blocks of rocks are trying to slide past each other. This one would be similar to the San Andreas Fault. The Pacific Plate and the North American Plate are trying to slide past one another. One's going in one direction, the other's going in the other direction, and stress builds up, and eventually that stress energy is released. The longer that it takes for an earthquake to happen, the more the stress that's built up. The more that stress is built up, the bigger the earthquake it is. And we'll talk about that in another section coming up. But if you want to think about what it looks like here, if you're looking at our boxes of science, of faults, here's that fault plane. And what's happening is this box is trying to go forward. This box is trying to go backwards. So what happens is the stress builds up, and then eventually one slides past the other. And when that happens, you get stress built up, or stress released, and you get an earthquake, just like that. So in your book, on page 225, is a great picture of kind of what happens in a strike-slip fault. You can see a farmer's field actually looks like it's split. Looks like the rows kind of slid past each other. So that's pretty cool. So take a moment, take a couple ticks here, and get a picture drawn for a strike-slip fault and a normal fault and a reverse fault. If you need to take a pause, go ahead and take a pause there. You can practice this if you want. If you can think about this, if you're pushing them together, that stress is pressing together, and then when the stress is released, one slides up when they're pressing together. That is a reverse fault. Remember that. If one moves up compared to the other, that's a reverse fault. If you're going this way and one slides forward or one slides backwards from each other, that is a strike-slip fault. And then if you're trying to pull your hands apart and then one slips down compared to the other, that's a normal fault. Just remember that. If they're pushing together, one thing you have to remember is that's convergent. Another thing that you have to remember is when they do end up pushing together, one slides up And if one slides up, that's a reverse fault. If they are moving apart from one another, we know that that's divergent. We know that when they do finally break and one slides down compared to the other, that's a normal fault. And when one slides forward or one slides backwards compared to each other, we are looking at that being a strike-slip fault. So hopefully that's fairly clear. You might want to just, again, if they're pushing together, stress is pushing together, and one slides up, reverse fault. If they're trying to pull apart, and one slides down, that's a normal fault. And when they are trying to slide past each other and one slides forward, that is a strike-slip fault. So, your assignment today, which will be in a regular Google Doc, it won't look like a smartboard slide, but the first one says, what causes earthquakes? What causes earthquakes? Now, if we go back in our notes, a sudden release of stress causes earthquakes. Look at that. How strange. Why would I have given you the answer to that? That's weird. Question, why do most earthquakes occur along tectonic plate boundaries? I'm sure I have that somewhere in your notes as well. And then the third question says, what are the main directions of stress on the blocks of rocks at a normal fault? So what they're asking there is, at a normal fault, are the rocks pushing together? Are they pulling apart? Are they sliding past one another? So you'll have to just simply say at a normal fault they are pushing together, or at a normal fault they are pulling apart, or at a normal fault they are sliding past it horizontally. And then you have to do the same. What's the direction of stress for a reverse fault? And then what are the directions of stress for a strike-slip fault? Once you get that done, make sure you turn that in. I would strongly urge you to go back and look at your notes, and then go back in your book on page 221 and read section 7.1 to page 225, just to kind of get some background information, stuff that I didn't get into the notes. Obviously, it's just a little too long. So anyway, with that being said, I'm done talking, and good luck. Finish that up, and we'll correct this tomorrow.